Hi, this is Mr. West, and today we're doing a Khan Academy tutorial on one-step addition and subtraction equations. This is the intro to algebraic equations, and a lot of students really struggle with the introduction of variables, which is the letters that are combined with the numbers. So the letters are essentially treated as a question mark, and let me give you a scenario that makes it a little bit easier to think about algebraic equations. So let's say we go to the store and we don't know how much money is in our wallet. We spend $9 and then we end up, as we leave the store, with $1. How much do we start with? It's better to think of this problem as in terms of a start and a finish. So we start with something. We don't know what it is. We subtract, or we take away, or we spend $9 and we are left with $1. How much did we start with? A lot of students can do this in their head, and that's fine if they can do it in their head, but I would like to encourage you as the viewer and any student to try to figure this out using the algorithms that we have for algebraic equations, so that when we encounter more difficult problems, you can do it, okay? So long-winded, but here's the short of it, is we start with something, we subtract $9, and we finish. If you didn't know how to do that in your head, how would you go about this? You're like, okay, well, I'm going to start with my finish now. Okay, so I'm going to start with the end, and I know if I spent $9, if I want to see how much I start with, I need that $9 back. So I want to get that $9 back, and then I can see how much I started with. Now, what is that getting it back? What is that equivalent to? That's equivalent to addition. And this essentially brings us to inverse operations. So inverse operations are critical in math. Looking for a new color here. So inverse operations, and that's how you are going to solve all equations, is through inverse operations. So we already said the opposite of subtraction is addition. We can get that money back by adding it back into our wallet instead of subtracting it from our wallet. On the same token, if we wanted to find the opposite of addition, okay, so if someone gave us money, $9, and we wanted to find out what we started with, we would subtract it. We would give it back. And then this is for later on. There's multiplication. The opposite or inverse of multiplication is division, and then the inverse of division is multiplication. So these are kind of like your tools to help you solve equations. And we're really only going to be talking about these ones today because of the title, one-step addition and subtraction problems, okay? So let me set this up again. We have x minus 9 equals 1, okay? Now the first thing I like to do is I like to set this up in terms of a left side and a right side. I think it's easy to think of that because we're thinking kind of like a scale. So if we have a scale here, we need to keep equations balanced because this equal sign means both the left side and the right side are equal. Okay, so if we were to, for example, add that $9 back, okay, that's what a lot of students do. They're like, oh, I 1 plus 9, I know that's equal to 10. However, if I add 9 to the right side and not to the left side, my scale is going to tip down and it's no longer going to be equal. So I really need to make sure it's balanced by adding or subtracting or whatever operation to both sides. So here I added 9 to the right side. I need to do the same thing to the left side. And the whole reason why we do that is we notice that if we add 9 to a minus 9, those two things cancel each other out. It's the opposite, so it undoes it. Another way to think of this is if I were to take 9 steps forward and then take 9 steps back, I would end up right where I started, okay? I would start right there, and I would end right there. It undoes it. So if I take 9 steps forward, I can undo that by doing 9 steps back, and I'm back to where I started, which was just the x. So the x is what we're trying to find. If we undo the operations that are taking place to it, a lot of people call this the isolation or isolate the variable, we can find out what the answer is. In this case, it's going to be 10. So we're going to type in 10 for our answer, and we can move on to the next one. So that was a long explanation, but I think a visual representation really helps students with this process. Okay, so we could think of this situation again in terms of like a wallet. Money is a great way to think of these problems. So we have, this time we can start on the right side. This would be our start, and then we'd finish over here. It doesn't matter. With equal signs, it doesn't matter if it's on the right or the left side. So we have an unknown value. We could even think of this as question mark plus 15. So we start off with some amount of money, and then someone gave us $15. And when we counted, we ended up with 27. How much did we start with? Well, you could take that 27 and you would subtract that $15 that somebody gave you, right? And then you'd find out how much you start with. But again, if you're going to represent this algebraically, it's important that you do the same operation to both sides. So we have 27 minus 15. That is going to give us 12. Okay? And then on the right side, this is the part that confuses students, but I'm telling you, try to do this even if you don't understand it fully, because the more you do it, the more it's going to make sense that you keep it balanced. Okay, we do the same thing to both sides. Here's our division of the left and right side, and this cancels out the 15. 15 minus 15. Another way to think of that is 0. Okay, 0 plus x. 15 minus 15 is 0. And if you have 0 plus x, that's just equal to x, and x equals 12. Okay, that's actually how most math teachers come to define it, is if we add 0 to something, it's just the same thing, and we're left with our answer, which is 12 equals x. And we'll get to how that works with multiplication in another video, but for now, we're just going to go 12 equals x, and that's going to be your answer for this second problem. Okay. Another situation, we can always think of money. Okay, so we have some sort of amount of money, and we go to the store, we spend $18. How much do we start with? A common thing I see people do is they're like, okay, they see a minus, they see an 18, they see a 3, and they do 18 minus 3. They're like, oh, I started with $15. But how could that make sense? How can we spend $18 when we only started with 15? Okay, that doesn't work out. Okay, at least not yet without integers. So we're going to do the opposite operation. We're going to just look here. This is what tells us what to do. We look at our variable's p. We want to do the opposite operation. So we see we have minus 18, so we're going to do the exact opposite of minus 18 and add that to both sides. That cancels out the minus 18, but on the right side, it doesn't cancel out. We're just going to perform the operation we see here. 3 plus 18 gives me 21. And that's my answer. So I have 21 for my answer for that one. And if I'm going too fast, make sure to just pause or rewind for any of your copying or note-taking needs, okay? Now I have add 22, so I have some amount of money. Someone gives me $22. How much do I end up with? Don't just say, oh, I must add 22 to 29, and that will give me my answer. No, that's not going to be correct. Okay, so we can do left and right side. That line I think helps. I never used to do that line, but students really like it. I'm going to see that I have add 22, so I'm going to do the exact opposite, which is subtract. I'm going to be left with k after this cancels out. And now I just have the simple operation, which is this one right here, 22 minus 9, and that gives me 7. I haven't talked about this yet, but you can also check your answer. And what you're going to do is you're going to substitute this in back into k and see if it makes a true statement. So I have 7. If I add that to 22, does it equal 29? And the answer is yes. Yes, it does. 7 plus 22 does equal 9. So we can type in 7 for our final answer. Okay, I'm going to go quick on these last ones just because I think you guys got it. Once you understand the basic process, these are pretty simple. So I have 19 plus n equals 30. I notice that I'm adding 19 to n, so I need to subtract 19 to n. Okay, see that? We have adding, this is a positive 19 that we're adding there to n, so we need to subtract 19, and I get n equals 11 for my final answer. Notice how I didn't like scratch it out this time. Okay, the more familiar you get, the easier and quicker you can do it. So we have 18 equals n minus 18. A lot of students might say 0 here, but that would be incorrect because we need to do the opposite, which is add 18 to both sides. That cancels out. This time I did it. And then we get 36 on the left side. One more to go. Okay, so I'm adding to k. Okay, a positive 18. So I'm going to subtract 18 from both sides. Okay, there's my equal sign. That cancels out. That was the whole point in subtracting 18, is to get the k by itself. And now I have 30 minus 18, and that's going to give me 12 also. So we had two 12 answers, right? Two answers of 12. And that's all there is to it. I hope you enjoyed this video. Make sure to check out other videos I have that are Khan Academy oriented. I have a lot of math videos, so go ahead and search that for help. And I look forward to seeing you next time right here on West Explains Best.